Yes, we welcome you back once again. This is PSSB. The channel is PSSB, Physical Sciences Silver Bullet, and the voice behind the channel is Richard. And we are not going to get tired of reminding you to subscribe. And those who have already subscribed, we appreciate you. We are not taking that for granted. Okay, we are continuing with the same question. Here, the question 1.3 says, state work energy theorem. Okay, what we normally tell our learners is that it's very good that you know the formula. The formula says W net is equal to delta AK. If you can put that one in words, the better. Then comes this question. The question says, use work energy theorem to calculate the speed of the trolley when it reaches P. So here they are telling us to use work energy theorem. So when you're tackling this question, it's very important to know that your first reward comes when actually you use work energy theorem. So it comes as that net work done is equal to change in kinetic energy. So what we normally tell our learners is that after this, you can expand it further. We know that net work done is equal to net force times displacement. So we can expand this one to become net force times displacement. People are saying, why don't you put cos 0 or cos theta? You have to know that net force is always in the direction of displacement. So that one is unchangeable, so this one is okay. So this one is equal to delta EK. So when you look at this expression, net force has come in. And how do we get net force? So this one requires us to have the free body diagram. So if we recall the free body diagram we had, this is what we have to remember. We had applied force here, and we had these two forces, which one is Fn and the other one was Fg. Now let us talk about these two forces. These two forces are not doing work. We'll look at that one when the question comes. They are acting perpendicular to displacement, and remember work is equal to F delta x cos theta, where theta is the angle between displacement and the force of interest. So this angle cos 90 is 0. So we are technically going to leave these forces. So the force which actually is doing work is our force applied. So if the force applied is the one doing work, how do we deal with it in this manner? So you have to know that what we call actually F net is the summation of all the forces which are acting. Actually, it's the algebraic sum of all the forces which are acting. Now, these ones have already cancelled out. Now, the only force which have is this one. So we can now say that if you were going to use F net, delta x equals to half mv f squared minus half mv I squared. Remember, this is the final velocity and this is the initial velocity. So with this case, our F net is going to be FA, and because it's in the direction of displacement, it's going to be FA cos 0 degrees. So that's going to be our F net. Then into delta x, then we'll have this mvf squared minus a half mvi squared. So this is the case we are having at the moment, and everybody knows that that cos 0 is 1. So altered, we are going to have this case now that force applied, if we multiply it with delta x, is going to give us this, the change in kinetic energy. At this moment, everything is here with the data we have. We can substitute. What is FA? Force applied is 10 newtons. And the displacement is given here, this one, it is 2.5. What we have this side is going to be a half, and the mass is 3 times the final velocity. The final velocity is the velocity we are talking about is the velocity at P. So minus what? A half times 3 times 0 squared. So this is the case we are having. So in short, we are going to have our 25 here, which is going to be 3 over 2 VF squared. And what do we have from here? We are going to have 25 times 2 over 3 equals to VF squared. So from this, we can proceed and find the square root and get VF. So because of the small space, let us use a different color here. So after performing that calculation, what is going to be our VF? It's going to be okay. So this is our VF, which we get from here. So that is that. So let us proceed and go to the next question. Yeah. Then comes this question, our last question of this setup. The question says, calculate the height h that the trolley reaches at point Q. So this is what we are having here. The trolley is going to be moving from P to Q and covering this distance, and covering a height h. So there are several approaches you can do on this question, but let us use the one which we think is easier and sustainable. So in this case, what are we having? The best approach is to start with a free body diagram. You have an incline, and on that incline we have this angle alpha, which we don't know at the moment, and we have this h of ours here. So what do? We indicate all the forces which are acting on this trolley as it's going up. Now you have to remember that there is no applied force here. So what are the forces which are acting? The one which we know which are acting, the first one is kinetic friction force, Fk. Okay. The other one is gravitational force, which is acting like here. But you have to remember that the method we are going to use involves use of components. So in other words, we are not going to use this Fg here. We're going to use the components of Fg. Now, the gravitational force has two components. There is one component which comes vertically downwards like this one, and that one's called Fg, perpendicular. And there's a second component which runs along the incline, and we call that one Fg parallel. Those are the two components we are going to use. This one, which is coming downwards, is counteracted by our normal force, which goes up. So technically, this is the free body diagram which we are going to put to use. And we are going to borrow the same work energy theorem which we used before. Okay, what does it say? It says net work done is equal to change in kinetic energy. And like I said before, this one is expandable to become net work done is equal to F net delta X equals to delta EK. Now the question comes, what is our F net? Because at the end of the day, we are going to be using this part here. So what are we going to have? We are going to have net F net delta X giving you delta EK. So what are the net forces? What's the net force acting on that body? So the net force is the sum of algebraic sum of all the forces acting here. But like I told you before, these forces here, they cancel out. So that we are remaining with these two forces. So then our net force is going to be made up of these two forces. It's going to be made up of Fg parallel and Fk. Now, this one is very important to notice that the body is going upwards. So if the body is going upwards, then upon that information, when you add these two forces, this is what you are going to get our F net. So our F net is going to be Fg parallel cos 180 degrees plus Fk cos 180 degrees. This is what our F net will be made up of. So what do we get out of this? What we get out of this is that, remember, cos 180 is minus 1. So we're going to get negative Fg parallel minus Fk. Then it's also negative. The negative has come there. This one is what we call our F net. So this F net we have here, what are we going to do with it? We are going to substitute it there. And when we substitute, because this is our F net now, which we are going to substitute there, as we are going to see as we proceed. Now, after substitution, we are going to come up with this. We are going to have negative Fk minus Fg parallel into delta X is equal to delta Ek. That's where we are now. But now you have to be reminded, this one is very important, that what we call Fg parallel is mg, that component is mg sine alpha. I'm sorry we are bringing in new information, but we hope that this is common knowledge to you. The two components of gravitational force, the Fg parallel is mg sine alpha, alpha being the angle of inclination, and the Fg perpendicular is mg cos alpha. So our Fg parallel is mg sine alpha. So when you substitute there, what do we get? We are going to get minus Fk minus mg sine alpha into delta x, giving you delta ek. So when you open up this one, what do you get? Minus Fk delta x minus mg sine alpha delta x, which is equal to delta ek. Thank you. So here you have to borrow information from somewhere. Remember that the question is looking for this height, and we are finding ourselves without height in the expression. How do we get height? Where is our height hidden? So you have to borrow trigonometric ratios. This is, oh, okay, the incline is in the other way. This is our incline. In our incline, this is what we call delta x, the displacement covered by the body. This is our alpha, this is our h. So from the SOHCAHTOA or trigonometric ratios, we know that sine alpha is equal to opposite, which is h, over delta x. So under this circumstance, what is our h? We are going to get our h as sine alpha delta x. Okay, now our h has come in. I want to remind you that what we have here is this, and that one is substitutable with h. So the equation has become minus Fk delta x minus mg h, which is equal to a half mv f squared minus a half mvi squared. So at this moment, all we need is to substitute. Yeah, for substitution, this is what we have. We know that the kinetic friction force is 2, is this one. So it's 2. We know that the displacement covered on the incline is 10. And we know that the mass of the body is 3 times 9.8 times h. And we know the mass comes again is 3. And the final velocity. Now this is where I wanted you to know. There's something which was said here. They said it reaches maximum height. So this is where your imagination has to come in. As the body was going up the incline, it was decelerating. So whenever they say maximum height, it means that the body stretched until its velocity became 0. and that is the maximum height, so where it can't go further. So in that case, first of all, our final velocity is going to be what? 0 squared minus what? A half times 3 times the velocity at P, which we found to be 4.08. 4.08. So that's what we are having at the moment. So when you look at this expression here, the only unknown is h, and it can be obtained through simple calculations. So this is what we get after substitution. Now, what do we do here is just rearrangement and collecting like terms. It is preferable that this unknown becomes positive. So what do we have here? We have minus 20 plus 24.97, giving you 29.4 h. What you get out of this one is 4.97, giving you 29.4 h. So what do you get as your h after dividing by 29 throughout 29.4 both sides? You get your answer as 0.17 meters. So that's what you go through to get that height. Don't forget to subscribe and also to like and to comment. We are eagerly waiting for you.